Hey team, in this video we're going to learn how we can use our quadrilateral family tree and the direction that we move up or down or across the quadrilateral family tree to determine if a shape has more than one name. First thing we're going to discuss is this. When we move up the family tree, our statements are going to be always true. Here's what I mean. What I mean is if I look at a square comes from rhombus and rectangle. So if I start at square and go to rhombus and rectangle, a square is always going to be considered a rhombus or a rectangle because it is a specific type of rhombus and rectangle. And because a square can be called a rhombus or rectangle, we can also call it a parallelogram, because rhombus and rectangles are parallelograms. And if I keep moving up, I can see that a square is also considered to be a quadrilateral, because if it's a parallelogram and I go up, I know parallelograms are a specific type of quadrilateral. Notice how I started at square and moved up. All of these names that we moved past are different names for a square. Let's look at another example. If I start at trapezoid and move up, another name for a trapezoid would be quadrilateral because it is a four-sided shape. A trapezoid is a specific type of quadrilateral. Now, let's think about another direction when we move down. When we move downward, our statements are sometimes true. So, for example, if I start at quadrilaterals and I said, all right, quadrilaterals, are they always trapezoids, sometimes trapezoids, or never trapezoids? Quadrilaterals are only sometimes trapezoids. They are trapezoids when they have one set of parallel sides. But they don't always have to be trapezoids. They could be parallelograms or they could be kites. So it really depends on how many pairs of parallel sides they have. Another example of a sometimes statement is going from parallelogram downward. When I start at parallelogram, not all of my parallelograms will be rectangles, and not all of them are going to be rhombuses. Some parallelograms might be rectangles if they have four right angles, and some of them might be rhombuses if they have four equal sides. So when we go down the quadrilateral tree, our statements might only be sometimes true, because it only applies to some of those shapes. Now, another example of sometimes true, and this is a tricky one, is within the parallelogram family, rectangles are sometimes rhombuses, and rhombuses are sometimes rectangles. It's when they share the same properties and become squares. So a rhombus is a rectangle when it has four right angles, making it a square. And a rectangle is a rhombus when it has four equal sides, making it a square. So that's kind of a tricky nuance that we will see sometimes. Lastly, we need to talk about the never ever statements. So moving across from parallelogram to trapezoids, or trapezoids to kites, or kites to trapezoids, or kites to parallelograms. These are never true. That's because they belong to different subcategories of quadrilaterals. Parallelograms, trapezoids, and kites are not related at all. A parallelogram will never be a trapezoid. A kite will never be a parallelogram, because parallelograms have two sets of parallel sides. Trapezoids have one set and kites have 0 sets. So moving across, those are never true. The only exception is that sometimes right here between rectangles and rhombuses, because they belong to the same subcategory of quadrilaterals.